Another important thing to consider as we edit data is this idea of map generalization. So suppose we entered data by scanning in a map, which is shown up in the upper left hand as truth here. And I would argue that truth is one person's truth, right? The outlines of those, let's say there are lakes there up to the northeast of the road. Those could be different sizes and shapes based on what season it is or how soon after a rainfall this map was made. But let's just start with the truth up there. If we wanted to represent that on a map and we were going to zoom way out on this map, we might go with the next option off to the right there, which is fused. We might just make that whole area one kind of lakey area where you're bound to find lakes, even though we're not perfectly representing the outlines at that scale. Another thing we could do is we could just take all of those outlines, and some of those would take a lot of little straight line segments to take in the truth map. We could just simplify that so that they're smoother, more generalized outlines so that we're not quite capturing all the detail, but we're still staying true to the number of lakes, and we're just simplifying the polygons. Another thing we might do is we might just displace the lakes. We might put them a little further to the northeast of the roads so that when this is viewed at a zoomed out scale, we're not seeing those things right on top of each other. Another way we could generalize this map is just take away the smaller lakes. So take away the 3 smallest lakes, leave the 3 largest lakes. So we're just omitting or just leaving those off the maps because by the time they zoom out, those things might just show up as a points as opposed to something that someone can identify as a lake. And this last example here, exaggerated, has to do with how we symbolize things cartographically. In this case here, as we zoom out, the road might be, if it were on a image, like a aerial photograph, it might be too narrow to see. So we might generalize that by putting in a symbology, a road symbol that's much wider than the road itself, so that we can see that as a map, on the map as we're zoomed out on that map. So here's an example showing 3 different maps. They're of the same area, but they were mapped intentionally at 3 different scales. The one in the upper right was mapped at 1 to 24,000. That would be the most detailed or zoomed in scale. And we can see there's plenty of room to put lots of details of the big marine lake and the surrounding roads on there. In fact, it also includes some map elements not found in the next map, like those contour lines that we can see on the map there, and the depth of the lake, which is the bathymetry lines. As we zoom into, or as we zoom in looking, well, we're looking at the same area, but now we're looking at a map that was drawn at 1 to 62,500 in the lower left-hand corner there. And what we can see is that the outline of the lake is smoother. There's no longer contours of depth inside of the lake. The contours of the land have also been taken off. And we've started to generalize this map in all of those different ways. It looks like most of the roads are still there. Maybe some of the dashed lines from the previous map that might be dirt roads have been removed. But and we can also see that the outline of the lake is a little smoother than it was in the previous map. The reason we do this is because if we were actually looking at these 2 in the way they were intended to be, this second map is not meant to be shown as large. So there's just not enough room to put in all that detail there, just because our lines take up some room, and there's just not the same amount of real estate and of room that we had to draw the map previously. The same thing happens at the 3rd scale shown in the bottom right, where it's now at 1 to 250,000. We're still showing the same area, but we had to zoom in way more than the map user who's typically using this map would probably be looking at this map. And you can see that more generalization has taken place. Now some of the little parts of the lakes are gone. Some of the roads are also gone. The lines are a little bit more smooth looking because they're being drawn for something that's meant to be displayed at a scale, something more like this. If we were able to compare all 3 of these at the same time, we would be comparing the upper right with the one to the far left with the one to the far right. So this idea of map generalization is really important to keep in mind when we think about what what lines or what polygons or we want to keep and what those lines or sides of polygons are going to look like.